Now we are going to continue with our design process. I hope you have your horizontal alignment from last week's example and also your vertical alignment ready, because we are going to use uh, these two sheets. Alright, so now we're going to construct our cross section. However, before we start, we need to construct the super elevation development diagram first. Okay, so you need to establish the points that we have calculated last week, the points of SS, TS, TP and SC for both ends of our road. So the first point is going to be point SS at 3 meters, somewhere here. Second point, point TS at 19, change 19 here. Okay. Don't use too much pressure on the pencil, just like a light lines. TP, change 35. SC 51. SC tailing 58.3, something here, somewhere here, and then TP 74.3, somewhere here, TS 90.3, and last one SS tailing 106, 106.3, somewhere here. So we have points of SS leading, TS leading, TP leading, SC leading, and then SC tailing. TP tailing and TS tailing, SS tailing. Next, you can draw 4 lines, 4 horizontal lines on top of your graph. One, preferably in terms of vertical here. Okay, it is in scale, 1 centimeters, 1 centimeters, 4. Okay, so now you have the boxes. So now our curve, okay, we consider from here to here, meaning that our curve is turning to the left. Turning to the left means right hand side is going up. The right hand side edge of the pavement will go up at the super elevated sections. So you mark the first point of SS. So this is SS, ES, TP, SC, SC, TP, ES, and SS. Alright. So the first point is going to be here. Okay, sorry. We need to extend this line. Okay. So the distance between the start of your road to point SS is only 3 meters. Here is change 3. Right? So this is too short lah actually, but for the sake of the design, that's okay lah. Not for the sake of the design, sake of the example, sorry. So the first point SS is going to be this point. It goes straight to point SC. So here is the 1, 2, 3. Okay, goes up. This one goes up. then it goes straight, then goes down until the next point is an SS over here. This side also you must have you must extend the lines. But make sure you for the guidelines, the straight line, horizontal lines here, you do not press too hard. Okay. The most important part is the diagram itself, not the lines. Okay. All right. Here it goes to the left, and here to the left. So this line, better just use pen so it is clear. It's not clear. Alright, so this is the right hand side. Right hand side. The left hand side will travel straight until point TP here. Okay, point TP. And then it will increase its elevation here, here, and here. So you'll have something like this. Okay, don't forget to mark the center line, which is this line. Alright, so you have 1, 2, 3, 4, 5 lines. The line in the middle is your center line. So the one here underneath at the bottom here is the left hand side. Okay, right. So now you label at the top here. This is positive 0.1, meaning that full super elevation at 10%. At the center line here is 0, and then here you have negative 3, because your cross section cross fall is at 3%. Negative 3, and here it is negative 0.1. Okay, so between 0 to 0.1, obviously here in the middle is positive 0.5. So you know that this point, at this point, the super elevation is 0.5. This point 0.5. At the top here is 0.1, meaning that it is 10%. Anything that is flat here, the cross fall is 3%. So you have positive and negative values here, here, here. Okay, where it crosses the line of TS, TP, and SC. Okay, so now we have our super elevation development diagram ready. Okay, next we decide the points that we need to construct our cross sections. In the instructions of your project, I've mentioned that you need 5 cross sections from the cut section and another 5 from the fill section. So if you are using this example, so you can choose your cut section either from this part or this part. And for the fill section, we have no choice. There's only one area of fill section. So let's pick our cross sections. Alright, maybe for this part we'll choose point 50, 60, 70, 80. Okay, 10 points. That's 70, 80, 80. So every 10 meters. Okay, so every 10 meters you will have your cross section. Let's try at change 50. So this is your diagram for change 50. Okay, what you need to do, okay, go to your horizontal alignment, go to change 50, draw a line more or less perpendicular to that point. Okay, in our case here it is on a curve. So go to change 50, mark 4 centimeters, 2 centimeters to the left, 2 centimeters to the right. So you will have point 1, 2, 3, 4, 5, where the middle point, point number 3, is the center line of your road. So now for every point, so for every point here, you need to estimate the height of the points. Okay, so I've written here for change 50 what is the existing height. Okay, your existing terrain height from the topography line. From the contour line. But please do not mark like what I've done in this example. Just have your notes elsewhere. Do not make the the topo map crowded. Alright, so change 50, point number 1, 50 meters, point number 2, 55, 60 meters, point number 3. Okay, point number 3 you can get either from the map, but the easiest and the more accurate way to estimate is from your vertical alignment. So you go to 60 meters, you look at the existing terrain here and read it from the axis. Where is it? 60? Oh, sorry, 50. 50. You get the value from the y-axis. 60 meters. So you have the terrain height, the actual height as 60 meters. Next point is 65, and the next one is 67.5. Okay. All right. Next, you need to know the design height of your road at that point. So again, you go to change 50 here. The existing height is 60 meters, and then this is your design height. Okay, your design height. Get the reading from the y-axis. Okay, so here what we have, the design height is at 50 meters. Okay, I've written here 50 meters design height. So actual terrain is 60 meters. Your actual road height is 50 meters, meaning that you are going down. You need to cut. All right. So from these values, you estimate what is the highest point, 67, and the lowest point is 50 meters. So you need what? 17 meters. Okay, 17 meters. So you decide, can you have the scale here or not? Can you fit in or not? Okay, try your best to fit in with the scale of 1 to 100 horizontal and 1 to 100 vertical. Okay, in our case here, I think that it is too high, so I've just covered a few meters. Okay, so 1 meter here, 1 centimeter is 1 meter. So I've start from elevation 48 here and end at elevation 60. Okay, of course we have higher points, 0.4 and 0.5, but it is for our case, if you are using this graph, it is quite impractical, so we just fit in whatever we can into A4 graph. Alright, so now you mark the width of your road and the reserve width. So your reserve width is 20 meters, so you need 20 centimeters. Okay, you mark 20 centimeters, and the middle part is the center line of your road. Okay, so this is 10 meters, this is 0, 5, 10, 15, 20 meters. You mark every centimeters. Alright, so now your center line is going to be somewhere here, and this is your y-axis. We've decided that the lowest point in our axis here is 48, highest is 60. Okay, so at 0 point here, this is point number 1. Okay, so we go back to our graph, we see point number 1 is 50 meters, so you mark 50 meters. Point number 2 is 55 meters, so you mark 55 meters, and so on and so forth. This is point number 3, we get 60 meters, so this is 60 meters. Okay, so you have your terrain more or less something like so. Draw a line. Okay, next you mark your design height. Design height is at 50 meters, so this is the center line, and this is 50 meters, so you mark the starting point of your road. Okay, alright, at change 50 we need to assess the super elevation values that we have construct just now. Okay, we are now at change 50. We go back here, look at change 50 and see what is the super elevation values. Okay, so super elevation value, right hand side is at the maximum 10%, left hand side also at the maximum negative 10%. Okay, so you draw from here, you assume this is a flat line, you just draw a guideline, flat one. Okay, and then you estimate the width of your road is 2.5 meters, isn't it? 1 meter, 2 meter, 2.5, somewhere here. So you draw 2.5 meters, 2.5 meters, 2.5 meters. So from here to the edge of your road, you need to estimate the height so that it is 10%. 10% gradient. Okay, since in our graph, both sides are similar, one positive 10%, the other one is negative 10%, so it is at the same gradient. So from here you estimate what's the point here, so that this is 10%, and from here you estimate the point here so that it is negative 10%. Okay, assuming that this flat line, the straight line here, is your benchmark. So you draw 10% to 10%. Alright. Next is your shoulder. The shoulder is 1.5 meters, okay, from your typical cross section here. Okay, Since this is cut, we only use this area lah, cut section. So you have here, here and here. So you have a shoulder and then another 1.5 meter before you reach the slope. Alright. Okay, so you mark another 1.5 meters. So here 1.5 meter, another 1.5 meters on the other side. Alright, what is the the gradient of the shoulder? Okay, like I've mentioned in the class just now, this part, since the prescribed gradient here is 5 and this is larger than that, so you need to follow this side as 10%. So it is the same. You cannot have this one -5, because otherwise it will become water ponding over here. So it must follow 10% and 10%. On the outer side, outer edge of the curve, the algebraic difference must be 8. So here is 10, so this is 2. 10 minus 2 is 8. So 2%. Okay, there's a bit of a mistake here in this diagram, because what I've drawn here is actually going down, but actually it is slightly going up lah, 2%. Okay, I've made a mistake here. Okay, next is your the slope of your verge. I have not specified in the specifications what is the slope over here, but I think you can use it as maybe 10%. Okay, 10% going down. So the reference point for this one, 10%, is this point. The reference point for your shoulder is this point, and the reference point, if you want to construct this one, is this point. So it is -10% going down. Alright, the same thing you construct at the other side. So you have reached here. Next is the slope. Okay, we are not going to cover slope stability analysis or the slope design. So you just construct a gradient of 1.5 to 1. 1.5 meters horizontal and 1 meter vertical. Okay, you just construct straight line here and straight line here. So you can see this is your original terrain, and this is your design height. So all this needs to be cut away. Alright, so this is chainage 50. Let's go at chainage 80. Oh no, 80, 70. Go to chainage 70. Again, you construct a line, 5 points, 10 meters to the left, 10 meters to the right. So we have our points here. Chainage 70, you estimate from the contour, and then here you get it from your vertical alignment graph. Here, the existing point you can actually get from your table. So you get chainage 70, existing point, not existing, design height is 48.1. Okay, so this is your design height. This is chainage 70, isn't it? Oh, 70 should be here. Okay, 48.4. 48.4. That's your design height. Okay, again, you use those height to construct your x-axis and y-axis. X-axis not a problem because 20 meters. Okay, so you get this is 0.0, this is at 10 meters, this is 20 meters. Okay, here is 5 and this is 15. Okay. Again, you construct the you adjust the scale of the y-axis so that if it is possible, you can include every point. All right, so 0.0 here 50, number 2 47, existing terrain here, and then 45 down here, and then 47, next is 55. So you have something like this. Okay, where is it? Okay, in this topo map there's a slight inaccuracy actually. Okay, this line here is 50 and this one is 50. So between these two lines, it is not stated what is the minimum point. Okay, I've estimated that the minimum point here is something at 45, but if you look here, it is not marked as 45, so it is actually flat. Okay, but for the sake of our assignment, again, actually here there's a line that where the minimum height is 45, but that's okay. Just ignore this part. Okay, just be aware that I've considered that the middle point here, it is 45. It is not flat, 50 to 50. Okay, so again, you have your natural terrain. All right, so your design road height, the elevation of your road is at 48.4 over here, 48.4 somewhere here. So you mark with a straight line. Okay, so the same process, we are at change 70. You go to your super elevation diagram, change 70 somewhere here. I think you should just use this one. Change 70 somewhere here. Okay, so you need to estimate. For the sake of our example here, I'm going to assume that channel 70 is in the middle in the middle between SC and TP. Alright, so whatever it is, here is 5%, here is 10%, so in the middle is 7.5. Here it is -3, this is 10%, in the middle is, sorry, where is it?